Hi everyone. Today on this occasion of Pi Day we are here to ask the question, to be or not to be pi, and to give you a small glimpse of non-Euclidean geometry. The constant pi appears at different places all over mathematics. One of the very first encounters of pi happens in school when we learn that the interior angle sum of any triangle is pi radians or 180 degrees. But does it always happen? The answer, as you have already guessed from our initial question, is not always. Imagine this saddle-like surface and draw a triangle on the surface. Turns out the angle sum of the triangle will be always less than pi. This weird geometry is called hyperbolic geometry. This is different from our usual plane surface geometry. What we do is that, we take some usual behavior of our plane geometry and replace it with similar but not the same behavior. For hyperbolic geometry, we take the parallel postulate and replace it. Usually, if we take a line L and a point P, then only one line parallel to L can be drawn through P, but in hyperbolic geometry, given the bottommost yellow line, two parallel lines, one yellow and one pink, can be drawn through the highlighted point. These kind of geometries where weird things happen are called non-Euclidean geometry. This bigger family includes hyperbolic geometry as well. A beautiful visualization of hyperbolic geometry is this picture. Imagine yourself inside the picture, walking towards the edges starting from the center, and as you get closer to the edge you shrink to scale as depicted. That's exactly what a person on the hyperbolic surface will feel. The picture is drawn by this man, Maurits Cornelis Escher. Although he was an artist by profession, his artworks have always carried numerous beautiful and precise depiction of abstract mathematical objects. The impossible triangle in the picture, waterfall, and infinite staircase in his picture, ascend and descend, are just two examples of that. To know more, please check out the given link. These beautiful geometric constructions are called manifolds and are extensively studied in a branch of higher mathematics called differential geometry. Manifolds are locally Euclidean, which means if we keep zooming at one point it starts to behave like our usual Euclidean plane surface. Another branch of higher mathematics which also deals with different kind of weird-looking geometries is projective geometry. The triangle-like picture in the bottom is an infamous construction in projective geometry called the Fano plane. This branch of mathematics has numerous practical applications in theory of coding and cryptography. So on this Pi Day, get a sheet of paper with pencil and let your imagination run wild like Escher. Happy Pi Day everyone!